Hello, welcome back. This is the second year now that we're in. Well, I'm in college anyway, but basically this is the first video that I'm doing of my second year of revision. So essentially this is C3, the start of C3. Now I'm going to try and refer to different bits of the course, partially bits that you've not done yet if you're watching this in the order I've organised it in my files. So what we're going to be doing today is something called Algebraic Fractions. I don't think this will take more than about 10 minutes. If I go on 15, you never know. You never know. But see, I'm going from this class book, so if you're in my class, which my vast majority of you I hope aren't, not for any reason, but I'm going to be making reference to this. So if you're in my class, it's the C3 classwork book that we got given at the start of the year. I'm assuming you're going to be watching this at the end, right, for our exams. So hello, future people. Okay, so anyway, on to the maths. This, as I said, won't take more than 10 minutes. I'm just going to go through a few of the exercises in here, give you a bit of ins and outs of the topic, the main things to watch out for, and then we'll go through one or two past paper questions. Otherwise, I think this is going to be fairly self-explanatory. Okay, so algebraic fractions. What are algebraic fractions? Well, same as a normal fraction, so I'll give you one here. So 23 over 50. Now, I don't know what that is. You don't know what, well, you might do if you type into your calculator and know what that is, but that obviously, you're not thick people, that is a fraction. Now an algebraic fraction is exactly what it says. It's a fraction, but with your x's and your a's and your y's in there, and I could go and make a whole story about x's and y's, but essentially that's what we're dealing with here. Okay, so one of the things to watch out for is what someone will see is if they see this kind of equation. So I'm not going to simplify this, and it's not going to be perfect for what I want, because I'm just going to come up with it off the top of my head now. What you might see, well actually no, this will work perfectly. So what you might see is x take 5 over x. Sorry. I've just used one out of the book. I was going to be trying clever there and use one out about my mind there, but didn't work. Yeah. So do it quite big. So 2. Sorry, one sec. 2x plus 6 over x plus 3. Now, what the first person might see, this is why this is a little bit more complicated than it first seems. So what the first person might do is walking along and they'll see that equation just lying about in the street and go, oh yes, what we can do with that is we can say, oh, 2x goes into x 2 times, so that's 2, and 6 goes into 3 2 times, so that's 2 plus 2, it's 4. I don't know how you'd work like that, but essentially what I'm trying to get across to you there is they'll just leave it as 2x plus 6 over 3, 2x plus 6 over x plus 3, sorry, and they will try and just do the fraction straight away. Now essentially, obviously that's not the right answer, but you get where I'm going from that. Now the eagle-eyed viewer will spot it there as I'm waffling along. I'm trying to make a point of simplifying common factors. So what we've got x plus 3. Now you need to ask yourself, do any of the factors go into the factors above? This one does nicely, that's why we're doing it as the first one. So we've got x plus 3 here. Now I want you to keep in your mind that x plus 3. How can we relate it to the top half of the fraction? It doesn't necessarily always work like that. You could do it the other way if you wanted to. But in this instance, because the bottom, the denominator is smaller, generally going to fit into the one on top. Now what we could do is what I'm going to go on to in part of this later video, is we could turn it into a algebraic division, a long algebraic division like we did in C2. And again, you can refer to that on my channel if you don't know what I'm talking about there. But essentially, we're x plus 3, 2x plus 6. Now 2 times x plus 3 is 2x plus 6. So basically all this is 2x plus 6 is an expanded version of 2 times x plus 3. So we're going to write that in as I've just said it, so x plus 3. And then that's x plus 3 on the bottom there. Now what I could write here is, because it's 2 times x plus 3 and 1 times x plus 3. Now the reason I'm doing that is you won't necessarily do that in an exam. But basically we've both given them a common factor of x plus 3. And the top one is 2 times that and the bottom one is 1 times that. Now it doesn't say 1 times x plus 3 in the original algebraic fraction. But you know, that's just to help you get to grips with it. I mean, it's fairly simple stuff, and this is the key bit. If you can do this bit, and you can do algebraic long division, because I'm assuming you've done C2 in Edexcel, you'll be perfectly okay with this. So what we can do, just make sure you can see it on the screen. I've gone off the screen there. Yep, that's perfect. So what we can essentially do here is go bye-bye x plus 3. We don't need you anymore. We've crossed you out. You're gone. You're nothing. And then what we're left with is 2 over 1, and anyone who's anyone should know 2 over 1 is 2. And then that gives you your answer of 2, which is different because we've got 4 before, because I don't know what I was doing there. I was a bit crazy, to be honest. Obviously that's what a normal person would do. But as you can see, that's what we'd call a linear equation, top and bottom. And you know, sometimes you get a quadratic over a linear, or a linear over a standard number one. Yeah, so that's how you do that. Sorry, just put my rubber down. There it is. So, okay, so I'm assuming you've got that. Just wind back if you didn't get that, but hopefully we spent a bit of time on that. Now, I did refer to it there in the previous bit of this video, and I said something about algebraic long division. Now, it said simplify the fraction, and we simplified it just there to 2. But, see, I'm going to use the same example, and I'm going to prove to you that we get the same answer. Now, generally, what you wouldn't do this kind of thing that I'm about to do, but I'm using the same equation so you can see that we get the same answer if we do it the other way. Or if I'm going to look like someone who needs help with maths rather than someone who's teaching. So, standard thing at the bus stop, you should be familiar with this by now. We've got the quotient at the top, which we're going to put there in a minute, and slightly different, but I'm going to, at the end, the way we do it is exactly the same. I'm going to explain something slightly different, so be on your toes. Okay, so 2x over x gives us 2, which is what we got before, so we shouldn't get anything else, so it should cancel. 2 times x, 2x, 2 times 3 is 6, take that away, that gives us 0, happy chappy, so the answer is 2. So exactly what we did before, in terms of the answer, but it's a slightly different way of getting there. Now on this particular example, purely because it was in the simplifying part of our workbook, if you were there at the beginning, we haven't got any other, we've got 0. This nicely comes out to be 0. Now that's not always the case. I can hear some of you in the background going, well, Will, what do we do when my pen's not trying to escape from my hand? What do we do when we've not got a 0 here? Well, if you cast your mind back to C2, what we did when we had a remainder, well, great. Just it's like asking a question, giving you the answer. So basically we called that a remainder and we said 6 remainder 4, x or whatever. But in this instance, what we do is we do plus, say if we had a remainder, not 0, but I'm going to assume, just to confuse you, we've not got 0 here, we've got 6x for example. What would we do? I mean we wouldn't, because we had 2 and you wouldn't have anything less than that in terms of the quantities of x's. So what we do here is we'd go, right, okay, so we've got a remainder, so we can't put it as, it's not going to be greater than 1, so we can put it as a fraction. And because we're dividing it by x plus 3, it's going to be a remainder of that so it's going to be a remainder in terms of that fraction, okay, because we're dividing it by that, okay. So 3 remainder 2, or whatever, this is a similar sort of thing, so it's 2 remainder, whatever it is 0, but it could be x or 6x or whatever. So it's a remainder of that fraction, and now the reason why we put it on the bottom is because we're dividing it by that, and it's how many percent, sort of a fraction of that, of how much is left. If that sounds better, great. If it doesn't, you know, bug off. But assuming we've got a remainder here, I'll put 0. That's the same. What I've just written there is exactly the same as writing equals 2. But assuming we had a remainder of not 0, of something that is not 0, you don't put it when it is 0. You know, that's how you'd answer it there. You put what we've got left over the fraction of what we're dividing it by, if there's any remainder. But the quotient at the top, that is always the first part of the answer. Now, what I'm going to show you now is a couple of key mistakes that students make. Obviously, having friends is one of them for me. But essentially, what in this part of the video I'm going to talk about now is we've gone through that method, and that was a very easy method. But what some students don't do, and this is more of a C2 thing, I just didn't mention it in my C2 video because I wasn't as smart then. So, you know, feel free to watch them C2 videos. But what students might do, and I've seen this myself, obviously not from me, doing it in class and looking like a right clown. When they are divided, now I'm not going to create a full equation here. I'm just going to write the bus stop bit and write my key points about it on the bus stop. So, assuming we've got it could be anything here. So this could be x cubed plus 3x plus 6, okay? And then we've worked out what we need to take away by doing what we normally do in algebraic long division. And we've got something like x squared take 2. And we want to take x squared take 2 away from x cubed plus 3x plus 6. Now, I could have wrote anything there, okay? I could have wrote anything. But I've chosen to write it like that to prove a point to you. Now, okay, so what would be your first instinct when you get to that point? Now, many of you might just be saying, oh, take away the top one. So I've zoomed it in so you can properly see. So I'll just take away this one from that. And we could just I'll go along and take that one from that and then that from that. But wait a sec, this 3, that's as a cubic, and that is a quadratic. We can't take a x squared away from x cubed because they're not the same thing. That's just like taking away b from a. Assuming they're not the same thing and not numerical. So that's why we can't do that. So how would we resolve this situation? Now, what I like to do, obviously not what my teacher told me to do, obviously I came up with this idea completely, but what we should do is, so I'm still going to have it be taken away x squared take 2, but to stop me getting confused, 0x cubed. Now we're not adding anything, I'm just writing 0 x cubed. 0 times x cubed is 0, but I'm just putting it there, so in my mind I know there's nothing that can be taken away. And I'm going to go on to this bit as well at the top here. I'm going to get crazy. And we had an x squared, if you remember, so x squared take 2 on the bottom, so I'm going to write that x squared. But we didn't have an x squared in the original top of the equation, so I'm going to write 0x squared. So this, again, doesn't make any difference to the equation, just makes the examiner go, yes, he's thinking about his answer. And he might be actually more lenient in the rest of the paper, you don't know. So 3x, and what do we have here? X squared. We didn't have an x on this side, so we're going to put 0x plus 6, and we take 2. Now see how much easier that is. If you just look at that equation there on the board, how much easier is that to take away now? Because all we have to do is look up and down. We'd have to faff around looking all the way over to the right or all the way over to the left just to get our answer. So hopefully that is algebraic fractions. Now what I'm going to do now is I'm going to give you a few questions and do the exam solution thing, obviously not ripping them off at all, but you know, if you're watching, you do good videos, just a compliment, and that's why I'm copying you. Obviously better, because I've got a bit of humour. Hello, welcome back. I just had a little break there while I try to find some exam questions to do, and I have. You'll be glad to know. So again, this is the second part of the algebraic fractions topic. So exam questions. Now this is just a compilation of some exam questions from my book. So again, if you're in my class, you can just revert to the exam past paper questions on page 8 if you're on the book. If you're not, just pay attention. We'll go through them together. Okay. So the first one says, oh wait, just remember, one thing I forgot to tell you. In algebraic fractions, you take away fractions from each other, you've got to make sure they have the same denominator. And same denominator. So just do what you normally do. I don't think I need to go through it on the board, but comment if you want me to go through it. I'm just assuming you can make denominators the same, and you're fairly familiar how to do that. It's the same in numbers as it is doing in algebraic fractions. Just you do it with x's instead of your standard numbers, whatever. I'm just going to go through the past paper questions, assuming you know that. If you don't and just want to go through it, let me know. Okay, so past paper question number 1. Don't worry, I'll be rubbing them out when I finish with them. So 2 brackets 3x plus 2. I'm just going to write out the fraction and I'm going to tell you what it's asking. So 9x over 9x squared, take 4. Are you taking that away from 2 over 3x plus 1? Yep, that's right. So, just to recap that, what it says on the board, 2 brackets x, 3x plus 2 over 9x squared, take 4, take away 2 over 3x plus 1. Okay, so if you're feeling confident, you can have a go at that and we'll go through it in a minute. Okay, so welcome back if you've had a go. Okay, so the first thing that we are going to do in this, obviously we're taking it away, so they need to have the same denominator. So we're just going to see what else we can simplify here. So you leave a 2 brackets 3x plus 2. Don't expand it yet. What we're going to do is try and factor this down into something else. So 3x, because it's an x squared, so 3x, bracket open brackets, 3x, so you get your 3x squared, and, oh god, sorry, one sec, just, sorry, not really slick, this is it, alright, yeah, okay, sorry about this, yeah, there they are, just don't want to start doing something wrong. Okay, so what we need to do is factorise that. So it's plus 2 and take 2. So that's going to cancel to give you that. Take away 2 over 3x plus 1. Okay, so what can we do here, right? As you notice, hopefully it's annoying me because it doesn't look like you can see that very well. What you can see, if you can see, is we've got 3x plus 2 over 3x plus 2. And all I've done, I've not times this, that's the key thing you need to know. I've not times it by anything. I've just expanded this. Just an expanded version of that. So we can cross these out, like we said to them before. So we can say goodbye. So we cross it out, so that's 2 over 3x, take 2, take away 2 over 3x plus 1. Now this is the thing I was saying before, because they're not the same denominator, that's what we can work with now. So if I bring this back up here, set me out the way now. So what we need to do is 1's over 3x take 2 and the other 1's over 3x plus 1. So if you times a fraction, so with one that's got over 3x plus 1, if we times the other equation by 3x plus 1 over 3x plus 1, we're not doing anything, we're timing it essentially by 1, but we're putting 3x plus 1, 3x plus 1 on the bottom, so we've got the same denominator, as it were. Obviously the same for the other side. So I'll just do that, so 2 brackets 3x plus 1, and then we could do that over, we're not getting rid of the 3x take 2, so we've got to keep that, 3x plus 1. Do the same for the bottom, the other side, sorry, so 2 brackets 3x take 2 over 3x take 2 is what we're taking, what we're times the other side by, but you don't need to worry about that, so 3x take 2, 3x plus 1, and now what you could have done is simply just simplify this as to one fraction instead of breaking it up like this, but I'm just doing it on the right here so you can see how we're getting along. So obviously then what we're going to do is we are going to put it, just going to put it over one bracket now, so that's 3x, sorry, one fraction, take 2, 3x plus 1, and then what we're going to do is expand this and expand that and put it in big brackets and take it away. So I'm sort of cutting this step a little bit. So 6x plus 2, take away 6x, take 2. It's key to put these in brackets because of something I'll show you now. Sorry, my writing's a little bit scruffy there. I was sort of trying to lean out the way. Were you? Okay, so what have we got there? Now the reason I put this in a bracket is because this here minus, what we're doing is 6x plus 2 take away 6x take 2. So we've got a double negative there. So we're adding 2. So basically what we're doing is with 6x, these two cancel out. And then you plus 2. And now it's not 0 on top, that's what most people think. 2 take away minus 2, it's actually 2 plus 2 essentially. So it's 4 over that. 4 over 3x, take 2, 3x plus 1. Now some of you might be going, oh well it's a fraction, that's not a number, that's not an integer. But that's what it's actually, which is simply simplify the fraction. Have I done that right? Oh, no, damn it. Spotted a mistake there. If you spotted that before me, well done. This should actually be 4. So this answer is actually 6. Sorry, just had to check my answers there. Good job I spotted that. Yeah, so that should have been 6. So that's essentially how we do that question. Just going to do another one now. Going to do one more. I'm going to choose around one. Hopefully one that I can get the answer right to. Not like a right pleb, trying to get it right. Sorry about that. Just trying to choose one now. Guess we'll do a similar one actually. So it says express. So this I'm gonna label this as question 2, but for them people who are going through the book, I'm gonna do question number 5. So that's 3x plus 6. I think this book is so bad. It's not just my eyesight. I'll show you. Obviously, complimenting the college there. Their excellent printing facilities. Got to work to decipher what that is. So x. So it's 3x plus 6 over x squared plus x. So this may end up being completely pointless. 12. Take away 2 over x take 3. So just to repeat that in my muffled voice, that's 3x plus 6 over x squared plus x take 12, take away the other fraction of 2x, 2 over x take 3. Just make sure, because I wrote it down here, I've got it right. What is it for? Yes, that should be right. X plus. Oh, sorry, that's 6 is actually a 5. Sorry about that, just bad printing. Okay, so what will we do with that one? Well, we've got a as you can see, a quadratic here. So whatever we're going to need to do, we're going to seem smart, give ourselves an extra step. And simplify this. Well, seems smart and make it easier. So, right, same top half of the fraction, simplify the bottom, so basically put it in brackets. So if you can do that while I'm doing this and see what we get together, if you prefer that or just whatever. Over 2 take x, 2 over x take 3. So to factorise that, what we do is x plus 4 and x take 3. So, a key thing when you're factorising, which I should have noticed actually, Yeah, and I'll use the camera zoom to point it out to you. Okay, so what we've got here is x take 3 over that, and then we've got a quadratic. Now generally what they do in the exam is one of them is going to be the factor. So what we mean by that is the quadratic on the left of x squared plus x take 12 is going to have, so one of the brackets is going to say x take 3, which if we look over there, it does. Generally that's what happens. So it's really easy to solve. The quadratic on that side of the underneath. You don't need to spend as long as I did trying to figure it out, because then you can just simply work that out. That's what I should have explained. So generally they'll give you a factor when you're taking it away, because say if we got two different factors of the quadratic on the left, we're going to need to times it 2 or 3 times to make it even, get the same denominator, which is going to be a bit messy. And as these are only worth about 4-6 marks at the most, that's going to require too much time. There's no other way to do it, and that's the way you'd have to do it if you're going to do that. It's a bit much pressure to put on. Okay, so assuming we've got this, the next step would be, so we've already got x take 4 and x take 3, we just need x take 4 on the other side, so the left hand side of the equation is going to stay exactly the same. So you can just rewrite out 3x plus 5 over x take 3, x plus 4. And we're going to take that away from 2. Now we're going to times both of this, top and bottom of the right hand side of the fraction, by x plus 4. And see, I'm not going to expand it just yet. So then we get the same denominator, and you can skip a few steps if you want to, if you're feeling brave, but I wouldn't advise it, probably because I'm a bit thick, so not that I should be mentioning that. Okay, so that's what we've got so far. Now we're going to expand this now after I've done that step and put it over one bracket. Sorry, my writing is a little bit pants today. X take 3, so we can just assume one big equation, 3x plus 5. Remember, don't forget the brackets, so it's going to be 2x plus 8. And if we take away 3x plus 5, take away 2x plus 8, take away 3x plus 5. 2x plus 8, take away from 3x plus 5, sorry. The 3x and the 2x is going to make x. They got together and had a good time. The 8 take away the 5, that leaves you with minus 3, so x take 3 over. Now this is quite a coincidental one, you need to be careful with that. So most people go, oh well, I've simplified it, that's it. But you need to keep paying attention, because there's likely to be another step. You think, what else could they ask me? So x plus 4 over x take 3. Now what the eagle-eyed viewer may have noticed by my comment there, is we've not quite done yet. There, I'm guessing you probably already guessed it already. We've got 2x take 3s, one on the top, one on the bottom. Now we can cancel them out. We've not times it, we've not done anything. So just cross it out there. Now you go, well there's nothing on the top. Well essentially there's still 1 on the top. So there's 1 over x plus 4. Because if we just wrote x plus 4, what we're doing is we're doing the reciprocal of the negative reciprocal of x plus 4. If that makes any sense. So that's your answer. And that's what I wrote down. Should have been, because that's the right answer. Okay, so that's the end of algebraic fractions. If you want me to go through any more past paper questions, just give us a shout. Otherwise, I'm assuming them 2 questions are enough and proved my other point that I was actually trying to make towards the end of the last video. But we'll see you in the next video, which is functions.